Warning: the stunts performed in this project were performed by a guy, so for your safety and the protection of those around you, do not attempt any of the physics you are about to see.
I'm Guy Bach, and this is the Burnout.
A burnout is possible in most rear-wheel drive cars. A burnout can happen when the force exerted, in the form of torque, overcomes the static force of friction between the tires and asphalt. Normally, this is observed as drive friction without smoke and tire spinning. A burnout is radically different because the exerted torque is so great that the tires begin to spin rather than produce forward motion. Force of friction is found using the normal force. The normal force is found by using the mass of the vehicle. In this case, the mass of the vehicle without a passenger is 1,515 kilograms. The mass is then multiplied by the force of gravity to create the proper units of force, which is newtons. After multiplying the mass and the force of gravity, the normal force is calculated to be 14,862.15 newtons. Force of friction is then determined by multiplying the normal force by the coefficient of friction, mu. There are two different types of mu values, static and kinetic. The static mu value determines how much force is needed to start an object to move. The kinetic determines how much force is needed to keep it moving. By multiplying these coefficients by the normal force, you can solve for force of friction. When multiplying these coefficients, you can see that the static coefficient leads to a greater force of friction of 18,480.45 newtons. The kinetic yields a lower force of friction equaling 11,295.24 newtons. It is a common misconception that only expensive, high horsepower cars can do a burnout.
Did you mean Hearst power?
No, horsepower.
Horsepower?
Close, but I was talking about this. Horsepower actually has little impact on the ability to do a burnout. The true force behind a burnout is torque. The sheer definition of torque is a twisting force that leads to rotation. Thus, the greater torque, the easier it should theoretically be to do a burnout. It is true that more powerful sport cars can easily do a burnout. That is because they are typically gasoline powered, and with higher horsepower, a gasoline engine will also produce higher torque.
ملك البيت تكيف لهم في الفليد كوب دافيل حبيبي كاسي عالدوبس حاسي كيف وبدي وب يا زول وات جنرال علاء مركن كاديلاك شوفوا مرتاح شارب شوية ياك سلاح معاك يا باشا ماسك كل حلة من هيب السيد الكوينزفيل البراونز فيلا من هارلم لين اللور ايست سايد نيويورك سيتي نيويورك بحبها بتذكرني بواديها عموما شوفني داخل 40 كلاب مع جينزي وفريقي شوية شراب ودخان امريكي رجعت البيت مع واحدة فريكي حبيبي شوف 2012 اهو من